Factoring can be hard. Understatement, right? Because what are you watching this video for if you think factoring is easy? Factoring can be hard, but sometimes to make it easier, we can leverage the fact that we know factoring and finding zeros are the same process, essentially. Like if we had this cubic, if I knew one of the zeros, I'd be able to factor it. And I'll show you what I mean after I find a zero. I can find a zero by taking, not a guess, an educated guess, based on what the possible rational zeros are. If there is a rational zero to this, which no guarantee, kind of a guarantee, but no guarantee. If there is a rational zero, there is a guarantee in this one, but it's going to be a factor of -6 over a factor of 1, or a factor of 6 over a factor of 1. In other words, the possible zeros are going to look like things that have a numerator of 1, 2, 3, or 6, or a denominator of 1 is the only factor of 1. These came from factors of 6. My constant term, these are factors of my leading coefficient 1. My possible rational zeros are 1 over 1, or -1 over 1. 2 over 1, 3 over 1, 6 over 1, or write any of the negatives. I already wrote plus or minus there, but I'll write -2 over 1, -3 over 1, -6 over 1. Those are my possible rational zeros. So if I try this whole list and none of them are zeros, I know this polynomial doesn't have any rational zeros. One of these is a zero, and I'm going to try plugging them in order of difficulty. Right, it's easy for me to plug in 1. It's hard for me to plug in -6, maybe. Not hard, but I'm going to start off trying to plug in 1, and I'll do it with synthetic substitution. If I plug a 1 into the coefficients 1, -6, 11, and -6, I'm plugging a 1 into 1x cubed minus 6x squared plus 11x minus 6. What I do is, first thing I bring down, and then I multiply by 1. 1 times 1 is 1. I add up my column, -6 and 1 make -5. Then I multiply by my yellow number. Multiply by 1, I make -5. Add up the column, I get 6. Multiply by my yellow number, 1 times 6 is 6. Add up the column, I get 0. What that means, what I just found out, is that f of my yellow number, f of 1, is 0. That means 1 is a 0, which helps me factor. It helps me factor because if 1 is a 0, that means one of my factors must be x minus 1. I can factor this into x minus 1 times something. So I made a step forward in factoring now. Where the real magic of this happens is that when I do synthetic substitution, the numbers down at the bottom aren't random numbers. I mean, this obviously isn't. This tells me f of 1. But these other numbers tell me what I get if I divide by x minus 1. It tells me that when I divided 1x cubed minus 6x squared plus 11x minus 6 divided by x minus 1, I got x squared minus 5x plus 6. Those numbers tell me these. So now I know I have here x squared minus 5x plus 6, which I can factor further now because it's quadratic. I know how to factor quadratics, right? This is the simple case of a quadratic where I have to find numbers that add up to positive 6, add up to -5, multiply to positive 6. In this case, it's going to be x minus 2 and x minus 3. Minus 2 and minus 3 add up to -5 and multiply to positive 6. So I factored it. Beautiful. Let's try another. Here, my possible rational zeros are going to be factors of 9 over factors of 1. So 1, 3, 9, 1. My possible rational zeros are 1 over 1, 3 over 1, 9 over 1, or one of the negatives of those. So I'll start off plugging in 1. If that doesn't work, I'll plug in -1. If that doesn't work, try 3, then -3. I'm just going to plug them in order of what I think is easiest, hoping that the earlier ones are going to work. I'll start off plugging in 1, check if 1 is a 0. And I'm plugging in 1 into x cubed minus 7x squared plus 15x minus 9. If I plug a 1 in, the first number I always just bring down, multiply by my yellow number. 1 times 1 is 1. Add up the column, -6. Multiply by my yellow number, add up the column. Multiply by my yellow number, add up the column. Wow, that worked out so nicely. Apparently, f of 1 equals 0. And when I factor this with an x minus 1 outside, what I'm left with is 1x squared minus 6x plus 9. And since I'm such a pro at factoring quadratics, I know that this factors into, it's the square of a binomial. It's x minus 3 times x minus 3. We'll do another one. Okay, this one now is more interesting because I have the leading coefficient. Not that much more interesting. I'm thinking about factors of 2 and factors of 6. Factors of 2 are 1 and 2. Factors of 6 are 1, 2, 3, and 6. So my possible rational zeros are 1 over 1, 2 over 1, right, 1 over 1, 2 over 1, or it could be 1 over 2, or 2 over 2, or 1 over 3, or 2 over 3, or 1 over 6, or 2 over 6. Let's just write these. Let's not get too crazy. 1 over 1, 2 over 1. 1 over 2, 2 over 2 I already wrote, because that's the same as 1. 1 over 3, 2 over 3. 1 over 6, 2 over 6 I already wrote, because that's the same as 1/3. Or it could be one of their negatives. Those are the possible rational zeros. I'm going to make my way down this list, but hopefully it's 1 or negative 1. If I plug a 1 into 6x cubed plus 11x squared minus 3x minus 2, I get 6 multiplied by the yellow number. 6. Add up 17, multiplied by the yellow number. Add up, I get 14, multiplied by the yellow number. Add up, I get 12. So apparently f of 1 is 12. An interesting fact, but not a helpful fact. So I'll try another number. I'm going to plug in negative 1. I mean, I know that's not going to work, but I'll try it just for fun of it. 6. I bring down. Then I multiply by that yellow number out front, and not that yellow number, negative 1. I get 6 times negative 1 is negative 6. These add up to 5. I multiply by negative 1 to get negative 5. These add up to negative 8. I multiply by negative 1 to get positive 8. These add up to 6. So apparently f of negative 1 is 6. Interesting? Not helpful. I'll try another number. This time maybe I already did 1, I already did negative 1. Let's try negative 2, just for the fun of it. Randomly picking. I'm going to plug negative 2 into 6x cubed plus 11x squared minus 3x minus 2. I bring down the 6, and I multiply by negative 2. 6 times negative 2 is negative 12. 11 and negative 12 add up to negative 1. Multiply by negative 2. Adds to negative 1. Multiplies by negative 2. Adds to 0. F of negative 2 is 0. So what must be a factor of this? X plus 2 must be a factor. Because negative 2 being a 0 means x plus 2 is a factor, because negative 2 will make 0 when I plug it into x plus 2. So now I have x plus 2 times 6x squared minus x minus 1. 6x squared minus x minus 1. Then I go and I apply my good quadratic skills to factor in this piece. I have an x plus 2. Let's see, 6x squared minus x minus 1. When I factor that, I would do 6 times negative 1 is negative 6. Things that multiply to negative 6 and add up to negative 1 are negative 3 and positive 2. So I'll rewrite this as 6x squared minus 3x plus 2x minus 1. I do some factor by grouping. I take out a 3x from the left side. I'm left with 2x minus 1. I take out a positive 1 from the right side. I'm left with 2x minus 1. Factor of 2x minus 1 is common to both of them, so 3x plus 1 is the other part of it. So I have 2x, I already forgot. I was just speaking so quickly, I already forgot. 2x minus 1 and 3x plus 1. That is the factoring of my original polynomial. I'm probably speaking so quickly you can't understand a word. This video is probably going to be trash. I hope it's not, though. I hope it's useful. This one, I have possible rational zeros. Factors of 9 over factors of 8. Factors of 9 are 1, 3, and 9. Factors of 8 are 1, 2, 4, and 8. my possible rational zeros, my possible fractions that could be zeros of this, are 1 over 1, 3 over 1, 9 over 1, 1 over 2, 3 over 2, 9 over 2, 1 over 4, 3 over 4, 9 over 4, 1 over 8, 3 over 8, 9 over 8, or the negatives of one of those. That's exhausting. I hope that it's not negative 9/8. If that's the last one I plug in, and that's what it is, I'm going to be devastated. Let's see. I will first try plugging in 1. Wouldn't it be convenient if it's 1? F of 1 is negative 6. Interesting, not helpful. By the way, I almost never will actually do the work to plug in 1. I can plug in 1 in my head, because it's just going to be adding up all of the coefficients, and I know how to do addition in my head. Humble brag right there. F of 1 didn't work. Maybe I'll try negative 1. F of negative 1 is negative 28. Interesting, not helpful. Let's try 2. F of 2 is negative 25. I'm learning all sorts of interesting function values here. I'm not yet learning zeros. Oh my god, did I just plug in 2? 2 wasn't even one of my possible zeros! Oh, I lost those 15 seconds of my life! I'm never gonna get them back! Okay, calm down. Let's try 3. I plug in 3. I'm plugging 3 into 8x cubed minus 26x squared plus 3x plus 9. Oh, now I've got the race. I have to beat my charger. Oh, goodness, so much pressure. 3. If I plug in 3, bring down the 8. Times 3 is 24. Adds up to negative 2. Times 3 is negative 6. Adds up to negative 3. Times 3 is negative 9. Adds up to 0. F of 3 is 0. If f of 3 is 0, that means x minus 3 is a factor. My remaining factor is 8x squared minus 2x minus 3. That itself can factor further into a 2x plus 1 and a 4x minus 3. If you want to know how I did that, see the other video. I want to save time in this video. Okay, fine, I'll show you. I'll show you, only because you asked so nicely. 8x squared minus 2x minus 3. Ta-da! 2x plus 1, 4x minus 3. Next up, we have this beast. My possible rational zeros. I'm not even going to write them. Well, okay, I'll write them. Well, no, I'm not. My possible rational zeros are 1 over 2, 5 over 2, 1 over 1, or 5 over 1, or one of the negatives of them. I'll plug these in, starting with the easy numbers, like starting with 1. If I plug a 1 into 2x cubed minus x squared minus 8x minus 5, I get f of 1 is negative 12. Next I'll try negative 1. F of negative 1 is 0. Lovely. That means that x plus 1 is a factor. And my remaining factor is 2x squared minus 3x minus 5. I go to the side of my paper, and I realize that 2x squared minus 3x minus 5 factors into x plus 1 times 2x minus 5. This x plus 1 in front is still here, so apparently this factors into x plus 1 squared times 2x minus 5. One more. My possible rational zeros are... I'll start off trying to plug in 1. Zero. F of 1 is 0, so x minus 1 is a factor. The remaining term is the quadratic x squared plus 4x minus 21, which I can factor because it's nice and easy, because it's a leading coefficient of 1. Numbers that multiply to negative 21 and add up to 4 are positive 7 and negative 3. That's how I factor this one.